let's jump in. Before that, let's review the agenda quickly. So we'll first talk about, whether DDoS can even be tested in the cloud. Many clients ask that question, so we'll talk about that. We'll talk about, MazeBolt radar software versus, traditional red team testing. It's kind of crucial for the topic of discussion that we're covering today. We'll look into a typical radar architecture just to explain the underlying technology. And then we'll start, and then we'll shift to the topic itself. Then we'll drill down into cloud. Why continuous DDoS validation is critical in the cloud specifically. And we'll talk about the solution that we've recently introduced for, with radar for Azure. So the question we hear from, many enterprises recently is simple. Can we safely test DDoS protection in the cloud? This concern is understandable. Traditional DDoS testing is associated with high volume traffic, operational risk, maintenance windows, legal review, etc. But the problem is that without validation, organizations are still relying on the assumption that their cloud DDoS controls are configured correctly. I've spoken to a CISO that I know for many years, and I was asking him, how do you protect your cloud environment from DDoS? And he did confirm that DDoS is an issue. They have controls in place. They don't know what it's doing. They don't have the telemetry. They just hope it's working. And he knows that if something happens, it can be problematic. So obviously, the assumption that the protection is in place is risky. We'll talk about why later, but I think that the point that we're trying to make is that the non-disruptive design of MazeBolt technology solves many of the concerns and basically, allow radar to run in production and to validate your cloud controls against DDoS. So before we talk about the technology, it's important to make one distinction very, very clear. Radar is not a volumetric test, okay? Joon, why don't you take us through the differences between traditional red team testing and MazeBolt radar?
Well, absolutely. I think it is vital to draw a hard line between the radar and the traditional red team, volumetric testing. So let's start with the operational impact first. Traditionally, the red team testing relies on high volume, stress-based traffic. And because of this kind of introduces a significant risks, it requires a strict maintenance windows and often, causes really a very downtime that it is trying to prevent. On the other hand, in contrast with the traditional red team testing, MazeBolt radar is designed specifically to prevent disruption. So instead of stress tests, we run controlled, non-disruptive simulations directly in your production environment, even during normal business hours, right? And completely eliminating the need for maintenance windows. Now, Moshe, I want you to cover, the actual coverage scope, that's highlighted in this chart, please.
Yeah, so you talked about some key differences, but the main one, the fact that these kind of tests requires maintenance window and a risk for downtime, you don't have a lot of time to test your entire environment. And, as everybody knows, cloud environments for large enterprises are huge, complicated. And so the scope of coverage is very limited. right? You can, you have about 2 or 3 hours to run your testing. Every attack vector takes time to execute, and within these 2 or 3 hours, you can just cover a very limited scope, and due to that, you cannot really proactively protect your environment, right? You can test human responses to damaging attack. You can test some of the controls in place to make sure that the operational rhythm is in place. But you cannot really identify vulnerabilities and proactively close them, and to basically protect yourself from a damaging attack in the future. So this approach of non-disruptive, DDoS simulations is a key. So, we talk a lot about the non-disruptive design. Let's talk about how it actually works. Joon, over to you.
Yeah, this is great. So really to understand how we achieve this non-disruptive and continuous validations, safely, let's look at this reference architecture that we have here. Let's start with the bottom because that illustrates what already exists. So the bottom half of the diagram, represents the infrastructure that are already in place in your environment, your CDNs, scrubbing centers, typically, that provides the cloud and edge protection, and your on-premise components like the edge routers, the WAFs that's sitting in front of the assets that's exposed and accessible from the outside. Right? So that's the current infrastructure that you already have. Now let's build on top of that in the existing environment to show how we MazeBolt radar, gain the visibility. The upper section of the diagram, introduces the MazeBolt platform. Right? We start with our multi-tenant, dashboard, which kind of serves as a control plane for reporting configurations and the attack, simulations. And to bridge the gap between your existing infrastructure and our control plane dashboard, we deploy radar detector into your environment. And it's a lightweight VM that acts as a data plane. And the radar detector integrates into your existing mirror ports, tap or span, across your existing security layers, and that serves as a observation checkpoint. And because we monitor these mirror ports after your CDN, after your on-premise scrubbing devices, your WAFs, and your routers, the detector can easily observe exactly what traffic successfully actually passed through each individual layers. Right? Now, that's how it gets deployed. But the critical piece in achieving the non-disruptive and continuous validation, it requires additional items. And Moshe, I know you're experts in explaining how our monitoring works, so please take it away.
Yeah, I can explain. So we have two components in the cloud, right? We have the simulations, which is basically the attackers, and we have the monitoring piece. So radar monitors the target services, basically, based on the targets that the customer provides, and establishes a response time baseline. During a live simulation, radar continuously tracks how the target responds, right? So when we say there's a simulation, we're executing the attacks at a low rate. If the target response deviates from the expected baseline, radar automatically triggers a simulation cutoff, okay? So at that point, the simulation will stop before there is any chance for non-disruptive action. There are also simulation checks, radar performs a monitor stability check to confirm the target is stable, a diagnostic validation to confirm that the detector is receiving expected data. If these checks fail, the simulation does not start. During the pre-checks, we also identify what we call the sweet spot rate, where below this rate, the target is stable, and above the rate, the target is jiggling. We expect the monitors to kick in the mitigation, actually, sorry, not the monitor. Expect the mitigation to kick in right there in this spot. So we know that this is the right rate to run the simulations of. So the result of these simulations at the end, again, non-disruptive, the results are a very, very nice report with a comprehensive list of vulnerabilities and associated recommendations that will allow you to improve your protection posture. This is the underlying technology. This is basically how it works. Now we can shift to talk about the cloud. Unless, Joon, you have anything else to add on this slide?
No, this is great. This gives us the baseline of how MazeBolt is doing the non-disruptive and continuous validations, which actually this slide talks about why it is critical. Right? So this is great kind of continuation flow.
Great. Okay. So why continuous validation is critical, right? So cloud environments are massive, right? You just deployed your environment, you put your controls in place, you think that you're safe, but the truth is that the infrastructure is continuously changing. We have large DevOps and infrastructure teams operating on it continuously and introducing new services, new APIs, changing routing, new security policies. That opens up the environment and drift the security controls that you have in place. You have to continuously validate and make sure that your environment is truly safe, and you don't only have those great mitigations in place. The attack surface is large, right? The attack techniques evolve over time. We've seen that with Mythos. We know that AI is changing the landscape. We cannot just kind of count on mitigations to on static mitigations to provide the answer without validation and required adjustments. And this is basically what we do. So as we said and as we explained in the previous slide, historically many people associated DDoS validation with on-prem. We talked about the firewalls, the WAFs, the CPEs. In the cloud, the same principle applies, but the visibility model changes. Instead of relying only on mirror tapping points, cloud deployments can use cloud-native telemetry sources. Okay, and I think that Joon, this is the solution that we are introducing. Let's drill down. Let's talk about how it actually works.
Yeah, let's take a look at how this actually architecture adapts specifically to Microsoft Azure, right? In typical cloud environments, especially in the Azure environment, extracting the right data and mirroring traffic, presents kind of unique challenges, right? Due to the TLS 1.3 introduction of PFS, and additional fact that the Azure, does not have native support for standard network mirroring, unlike AWS and GCP. So for us at MazeBolt, we had to address these challenges and yet still provide the safe, non-disruptive, continuous validations. So for us to overcome this, we adapted as a technology alliance partner with Azure, but we utilized a native log-based ingestion model using their existing log system called Azure Event Hub. So in a typical Azure environment, your primary protections are native services like Azure Front Doors, your app gateways, your app gateway WAFs, and sometimes API management, APIMs. As that's protecting your assets, that's exposed, again, accessible from the outside. So, as traffic flows from the outside to and through the protection layers to the end assets, the front doors and the app gateways, they all send logs directly to the Azure Event Hubs. And these logs are included both access level and the protection levels. Now, because of these logs are available with all these enriched data, the radar detector only has to subscribe to it with the read-only access to pull these event hub logs. This log integration actually gives us the exact and targeted visibility into whether our simulated traffic are successfully either blocked by the front doors, the app gateways, or if they actually slip through, these protection layers, giving us the vulnerabilities and missing configurations in protections. Because of you getting the highly detailed reports that breaks down where and which specific security layers are vulnerable, you can easily remediate these with a pinpoint focus. And because of the continuous nature of our platform, you can immediately validate those remediations are effectively, protecting your endpoints.
Yeah, great explanation, Joon. As you were explaining that, and I was kind of thinking, we've been working with, with many clients on this architecture. So quick question that will help us clarify a very important point. As a client, if I see this architecture, I'm kind of wondering, do I have to have Azure Front Door and is this the only architecture that these solutions support? Like, do I have to have Azure Front Door in place and then application gateway and the WAF, all connected to Event Hub, or there are other flavors?
That's actually great questions, right? So there are two parts to that question, two parts answers. One is scaling within the Azure, which we actually a few slides to talk about how we scale, but also integrating with different, vendors. We have seen cases where even with, Azure customers that utilizes just front doors, for example, right? And not utilizing the app gateways because they have their own choice of the internal, the application protection solutions in place. Also, the reverse is also true. We have customers who utilizes the app gateway for application protections, but not utilizing front door and uses different vendor solutions as a CDN. So the flexibility of integrating and incorporating other solutions into the Azure infrastructure is fully supported. And we will also, talk about in the later slides on how we scale within the Azure environment as well. So the short answer is yes and yes.
Right. So, okay. So, well, that's a great segue, I guess, to the next slide. Okay. So do you want to explain this, architecture?
So think of the previous slide as kind of reference architecture that really shows a simplified traffic flow to give you the understanding of how radar actually works. Now, this slide kind of demonstrates how our event hub integration easily expands to cover multiple VNets, which is very typical in the enterprise environments. Okay? The key takeaway here is the efficiency. The radar detector does not need to be deployed multiple times. It's definitely unnecessary. A single detector can seamlessly access multiple event hubs across your environment in multiple VNets. This kind of ensures you get the exact same continuous visibility and observability across all your VNets without adding, any unnecessary and additional infrastructure overhead.
Yeah. Okay. So that takes us back to the ground. So, obviously, real Azure environments doesn't really look like that. While you may have, your Azure Front Door in place, your app gateway, the environment itself is actually more complicated. We have different, different virtual networks, different resource groups, and I think that the main message is the flexibility of Radar to connect to multiple virtual networks or multiple event hubs. Essentially, let's talk about even more complicated setup.
Yeah, absolutely. Well, this actually scales even further, right? And this actually illustration actually demonstrates how the architecture, our Radar existing architecture, handles larger, even cross-tenant deployments in multiple subscriptions. Right? Today's enterprises are like MSSPs. You have multiple services, multiple tenants, because of not only because of the efficiencies, but the legal compliance reasons. You have to split those in services. So when we look at the reference architecture, we actually highlighted the control plane natively supports multi-tenancy, right? And this is exactly how it can integrate, right, and support this large scale. Right? That multi-tenancy support capability translates directly into the Azure multi-tenant, multi-subscription environments. So this kind of supports the flexibility and the scalability of our platform, reaching into not only individual tenant, but multi-cross tenants. Because of multi-cross tenants, you may actually need to deploy that lightweight, radar detector, but that's just the nature of kind of compliance that we need to live by. But again, the scalability, is really easily reached here using the Radar platform.
Right. Okay. So we have that flexibility is a key to to support different types of organizations, and I think that with that we're kind of covered most of the topics that we wanted to talk about today. We do have 5 minutes, which I wanted to keep for Q&A. Let me just pull a few questions, Joon. Okay, here's a good one. Okay. This is about compliance. We carry a lot of sensitive data. How do you comply to the PII PCI?
That's every conversations that we have with our customers and prospects, have this come up, right? So
the first
yeah. So my response to that is the compliance is built into our design. Okay? So we're only concerned with tracking our own simulated attack traffic. We never collect, process, or share any of your sensitive data because it simply isn't needed. So the platform functions purely by reading the statistical informations from the event hub logs, so we can detect if our specific simulation traffic bypassed your defenses, does identifiable vulnerabilities are present. So that means that your sensitive data remains entirely untouched and it's secure within your own infrastructure. Moshe, anything you want to add, in this?
Yeah,
Because
no.
I know you have a good understanding of our.
Yeah, no, I think
Fine.
that's that kinds of cover it. This detector here sits in your environment. It accesses the parser. It cleans up the information and passes statistical data up to our radar dashboard, and there's no PII or PCI concerns. And yes, I agree, Joon. This is the very first question customers prospects typically ask. Okay, next one. We have 2 minutes left. Okay. Here's a good one. Do you operate also in AWS and Google? I'll take that, Joon, with your permission.
Yeah.
The answer is yes. Okay, we can do. We have similar methods of connecting to central components in AWS and Google. It is important to say that from technology standpoint, AWS and Google offer built-in mirroring capabilities that allows you to basically get the data, from the endpoint. And sometimes, in AWS and in Google, this solution will not be valid, and we'll still need to look for, to integrate with central components, mainly due to encryption of data. But the short answer is yes. We have similar solutions for AWS and Google, and maybe even wider options there. We have time for another one. Yes, we have time for another question. Okay, this is a good one to you, Joon. How do you operate in large environments with many targets?
Oh man, we only have 1 minute to cover. This is like 30-minute conversation topic, right? But
yeah.
So let me quickly summarize it. To handle this kind of massive scale, efficiently, we use the AI-powered Smart Cycle. Okay, so instead of sequentially testing every single attack vectors and every target, our AI model, built on over 250,000 hours of accumulated simulation intelligence, automatically prioritizes testing the highest risk services and combinations first, right? So really goal is to reduce time to value and reduction of your DDoS exposures, as fast as we could. All right, 3 seconds.
Yeah, that's great. Okay. So thanks, Joon. I appreciate a lot, you joining me to this session. It was great. Thanks everyone for joining us today. If you'd like to learn more or explore how Radar can tailor to your organization needs, we're happy to follow up separately. My details will be shared as well as Joon's. We appreciate your time and engagement. Stay secure. We hope to see you in future sessions. Bye for now.
Thank you, everyone.